Okay, thank you everyone. So as Laura spoke about, we're going to talk a little bit about Unlock's value chains and the challenges and opportunities that we experienced throughout the course of the project. So firstly, I suppose, just to give an overview of who Farrelly Mitchell are and our role within Project Unlock. So Farrelly Mitchell are a food and agribusiness specialist consulting firm. We work right across the food and agribusiness value chain on a whole range of projects, including poultry projects. And within Project Unlock, then, we've undertaken various tasks which have sort of evolved over the course of the project. So the first thing that we did originally at the outset was that we were involved in the stakeholder mapping of the various stakeholders in the poultry sector right across Europe, and in particular within 5 target countries that we identified. From there, then, we looked at the value chain analysis, which I'll get to in a moment, but we've also completed various other tasks, including process simulation of the various demo cases. So that's the different ways that we're treating the feathers, so mechanical grinding that CEDROB are involved in, steam explosion from rise processum, and also microbial fermentation from bioextracts. We're also conducting technical, economic, and environmental analyses of these processes as well. So basically trying to conceptualize what the biorefineries would look like at a commercial scale, and seeing how feasible they are then from a technical, economic, and environmental perspective. We also conducted a regulatory review. So in particular, we looked at the animal byproduct regulations in the EU and what that would mean for Unlock's value chains if we were to have to, I suppose, align with the regulations that are in place. And then also from a standards point of view, what the Unlock products would need to achieve in order to be aligned with the European standards. So on the value chain analysis component then, as I mentioned, we did the stakeholder mapping, which then led to stakeholder engagement. So we reached out to various stakeholders within the European poultry sector, be it slaughterhouses and rendering companies, and I suppose interviewed them about their practices and the challenges that they face in their businesses. So we got a good understanding then of how the value chain sort of works. And from there then we could look to Unlock's value chains and how, I suppose, the challenges that are being faced currently might transition to Unlock's value chains that are being developed. And in particular, any barriers to entry to the novel value chains that would stem from those. From there then we also looked to the solutions. So we were involved with the various partners that are involved in the processes, and looking to see how we might be able to find workarounds for some of the obstacles that they were facing. So with that in mind then, I'll move on to the discussion. And the next slide. Perfect. So as Laura mentioned, we have the guys here with us and we have Philip online. So if I might just get you to introduce yourselves and your companies initially. Damien, if you don't mind to start. Just introduce yourself and your company.
Good afternoon, everyone. My name is Damian Gajdarenko and I am from company CEDROB, the Polish poultry meat producer. And I am responsible for the department, the quality of products and R&D of the materials produced from poultry byproducts. So our goal in this project was to deliver raw material for other partners in the consortium.
Thank you.
Yes, my name is Jonna Almqvist and I'm from Rice Processum in Sweden, and we are a Swedish research institute. And in this project we have been responsible for the steam explosion process.
Hi everyone, I am Evelien Beekman. I work at Normac OWS, and we are a lab that performs biodegradability and compostability testing and also does sustainability assessments, so life cycle assessments.
Philippe?
Hello, can you hear me?
Perfectly.
Okay, great, thank you. Well, hello everyone. My name is Filip Miketa. I'm CEO of BioMe company from Croatia. BioMe is a SME which is oriented in the field of R&D, but also we are manufacturers of different bio-based, biodegradable and compostable materials, granulate solutions. Also, we are manufacturing different semi-final and final products from our materials, mostly for agricultural sector, but also for a packaging sector.
Thank you, Philip.
Thank you.
So, Damien, if I might start with you. Obviously, CEDROB are responsible for the mechanical grinding process and the provision of feathers then into the Unlock's value chains from there. The demo plant that was constructed in Poland is obviously one of the main pillars of the project. Can you tell us a little bit about it?
Of course, about the demo plant, which was designed to deliver for the partners the safe, clean, and prepared with requirements, the feather mills. The installation was designed and now is located in one of our slaughterhouse in Kutno in central Poland. We choose this place because this slaughterhouse is completely renewed, so it was easy to design and implement this installation in this place. And the main topic was to upscale the grinding into industrial scale. And we achieve it. Now the demo plant is operational, and we have a few steps like grinding the feathers to size 5-15 millimeters, and washing and drying to keep it clean without physical and microbiology contamination. The line can work already with 200 to 300 kilograms of feathers per hour.
Great, thank you. And I suppose the traditional method of treating the feathers was, or is, feather rendering. So how does the mechanical grinding process compare with what you would traditionally have done with the feathers?
It's totally different because here we just prepare feathers with washing, drying, and grinding, and we have the same structure of the feathers. Still are fibrous, flexible, and mechanically strong. So in rendering, we have to break the keratin structure, denaturate the proteins to peptides, and then it's dried and grind to the size, and as feather mill can be used as feed material or fertilizer.
Okay, very good. Thank you. If you don't mind to pass to Jona.
Yep.
So when Damien is finished grinding the feathers, they're passed over to you guys in Rise Process them. And I suppose throughout the course of the project, the steam explosion technique has shown to be quite promising in terms of feather treatment. So could you just explain to us a little bit about what the steam explosion process is and how it works?
Yeah, sure. So steam explosion uses the steam to break down the structure of the feathers. And normally steam explosion is used on lignocellulosic biomass as wood chips, but now we tested it on feathers. And it works like we put it in a reactor or a chamber and put pressure on it. Pressure ranges from about 20 bars. Is it too high? And the temperature is about 160 to 220 degrees. And after a set amount of time, the pressure releases rapidly, and this causes the steam inside the feathers to expand, and then the structure of the feathers decomposes to get out the keratin.
Okay, very good. I understand it's quite a smelly process.
Yes, it is. We've all smelt it. Yeah.
Other than that disadvantage, what are the advantages of that process compared to the traditional feather rendering?
Since this breaks down the keratin more effectively, we get a more homogeneous composition of it. So if one wants to use the keratin as a material later, then that could be an advantage.
Okay, very good. Thank you. Evelyn, I'll come to you next. Or Philip, actually, I'll come to you next and leave the biodegradation to last, given that that's the natural flow of the process. Could you describe a little bit about what BioMe typically does and how your experience has been of processing the feathers within the project?
Yes, sure, Daniel. I can explain you. Actually, BioMe is doing, in reality, in our real world, existing world, we are doing the same thing what we are doing in Analog project. So I think that we perfectly fit with the main goals of this project. During implementation of Analog project, it was very challenging. I will be very honest with you. It was very challenging due to the many different reasons. The main challenge was to develop and to adjust our blends and compounds to the treated feathers, blends which were based on the different material, on the different polymers, natural polymers such as starch, thermoplastic starch, but also we used PBAT, PBS, PBSA, PLA, PCL, PHAs, different sorts of PHAs. I'm telling you this because we started with initially with 13 or 15 different polymer matrices, and we did many different variations of these matrices from the beginning. So the biggest challenge was in a temperature profile. Due to the thermal sensitivity of treated feathers, our blends should have a lower temperature profile, and this is something what we need to take into consideration. Secondly, except a lower temperature profile, our accent was on processability of the blends, and blends with a different, which contain different content and ratio of the feathers. For example, for mulch films, which should have thickness between 20 and 40, 50 microns maximum, we used feathers with a higher thickness. These are all some limiting factors. For a seed trace, for example, and formulations for this, rigid films should be very thick, but it was important to achieve flowability of blends and materials. But in any case, processability is a crucial step, because if processability is good, mechanical and other properties of final applications will be also good. And last, and on top of everything, our blends should be biodegradable in soil by 2 certification scheme, which is very hard to achieve. And this is also limiting us that we can use only several different biopolymers. So this is more or less it.
Okay, very good. Yeah, and it was interesting to hear earlier today during the course of the meeting about how the processability of the materials has actually been helped by the feathers more recently with some of the partners.
Yes, but actually, treated feathers have many advantages, such as, for example, price and possible availability. Also, biodegradation under different environments, such as industrial compost, home compost, and for us, most important, biodegradability in soil. From the other side, the biggest challenge was, as I previously mentioned, with the thermal sensitivity, processability, and also the smell, which is also present here, and which is also limiting use in some maybe different and other applications.
Okay, very good. Thank you.
You're welcome.
Evelyn, could you describe to us your role and Normac OWS's role in Project Unlock?
Yes. So within the project, one of our responsibilities was the biodegradability and compostability testing. So in the first stage, we did a lot of screening tests, mostly disintegration tests on the first materials. Also tested the feathers, the treated feathers, to see the effect of the different treatments on the biodegradation potential. And then we switched to the most promising materials. We did some more biodegradation testing. We first started testing in soil and in compost, but then later we also did home composting tests. We did tests in aquatic environments. And then finally, the final demonstrators, they were all tested for organic recycling, so according to the EN standard on industrial compostability. Also for the mulch films, we evaluated them according to also the EN standards on mulch films, and then also looked at the other environments like anaerobic digestion, also again aquatic environments, freshwater, marine, so yeah. And also a big part of the project was the sustainability assessment. So OWS also performed life cycle assessment of the final demonstrators.
Very good. And could you tell us what the most interesting or surprising outcome of the tests that you conducted would be?
What was not really surprising, but was still good to see, was that the treatment of the feathers actually had a really positive impact on the biodegradability. And also adding the steam exploded feathers to the polymer blends really facilitated the disintegration of the material. We also had one very surprising result. We tested some pure polymers with steam exploded feathers added in soil and in compost. And for PBAT, we saw a strange result. So normally with PBAT, we expect a lag phase in the biodegradation, and then it starts to degrade slowly, and the material with the feathers actually started to degrade immediately, which is what we expect due to the addition of the feathers. But then at some point, the sample with feathers actually started to slow down again, while the pure PBAT started to increase in biodegradability, which is kind of strange to us. But then probably this has to do with the microorganisms that started degrading the feathers first, and then had to adapt to the PBAT as their main food source, which probably takes some time. So actually adding the feathers in this case, it seems like it's made the lag phase disappear, but actually it did not disappear. It just moved, to later in the biodegradation. So
okay, so the microorganisms prefer the feathers.
Yeah, they really like it.
Okay, and I have one more question for all of you. So it's the same question, and it's: could you describe the main challenge that your organization faced throughout the project, how you may have addressed it, and then resulting from that, any opportunities that you might have seen?
For us, the main challenge is almost always the same. It's timing, and in this case, also the huge amount of samples that we had to test. As you mentioned before, we are always at the end of the process because we do the end-of-life testing. So we had a lot of samples still to test at the end. Still now a lot of tests are running, and also our tests, biodegradability and compostability tests, take a lot of time. So it's a challenge to get all the results in time.
Very good. Jona?
Yeah, so we had some challenges when scaling up from the 40-liter batch reactor to the continuous scale. And since feathers are very dusty and lightweight, we encountered some problems because the continuous reactor has an open screw system, and the feathers would just fly around in the whole building. So we had to adapt, and we ended up adding some water to it to prevent this from happening. And this actually made the process go much smoother also. And we also had some problems with dewatering of the bigger scale product, since it was much more than in the smaller scale. So we tried different dewatering methods, and this could be looked into more also.
Okay, so depending on the system you use, technically you may not have to wet the feathers if there was a closed conveyance system of some sort.
Yeah. In the beginning, with the batch, we didn't wet
Okay,
them.
very good. Damian?
From our side, the main challenge was upscaling the grinding of the feathers because of their properties and structure. So it's very hard to cut them to smaller particles, and we have the big issue with blocking the devices or heating to high temperatures, even almost burning the feathers. So we had to change the design because first we tried to grind dry feathers at the end, and we switched that we start the process from grinding the wet feathers from slaughterhouse. So the addition of water helped a lot.
Very good. Philippe?
Yes, sure. Well, as previously mentioned, the work was performed in the segments. In the first part of the project, we were more oriented in order to develop formulations, and in the second part of the project, we started with scaling up activities. And as previously mentioned, the biggest challenge was in this fact that we need to achieve adequate thermal profile, to achieve processability and biodegradation. So, but however, at the end, with the Unlock project, we clearly demonstrated that waste such as feathers can be used and utilized in demanding applications such as agricultural, mulch films, trays, foams, etc. After all, up to now, only BioMe performed 10 different trials related with development of formulations and 5 scaling up trials, which I don't remember that we did in any other project in so big and so large number of the different tests. And this was very challenging, but at the end, we are very satisfied with the coordination and cooperability of other partners. I'm using this opportunity to thank once again to coordinator, to Sarah, Alicia, also Elena and Gulen, they are all sitting there. Thank you for your cooperability. And yes, definitely treated feathers can definitely be used in production, but before commercialization, further commercialization, many parameters should be adjusted. So this is it.
Very good. Thank you. And thank you all.
You're welcome.
Are there any questions? Or online? No? Okay. Well, thank you very much.
Thank you.